Looking at the 4.1 to 4.3 review number 2, reviewing the first 3 sections in chapter 4. So the first 2 examples say solve by graphing. So these are both set up in y equals mx plus b. So I'm just going to go ahead and start graphing here. I got a y-intercept of positive 1. I got a slope of 3 over 5. 1, 2, 3, 1, 2, 3, 4, and 5. And then trying to be as accurate and as precise as I can, draw that line. This one has y-intercept of negative 2. And it goes up 3, 1, 2, 3, 1, 2, 3, 4, and 5. Okay. And the solution is defined as the line, the point at which they cross. And you can see that they don't. And hopefully you realize originally that the lines were parallel because they have the same slopes. So the answer to this is no solution. They do not cross. Okay. Looking at the next one, number 2, solve again by graphing. I'm going to go ahead and get these solved for y. So for this one, all I have to do is add a 5x to both sides. All right. So I'm going to come and give myself a little bit of room. Y equals 5x minus 2. Okay. So there is one equation. This one here, I'm going to add a 3x. Coming over here, 6y equals positive 3x minus 12 divided by 6. And y equals 1/2 x minus 2. Okay. So I'm going to go ahead and graph these two. I'll graph this top one first. Negative 2 up 5 over 1. 1, 2, 3, 4, 5 over 1. Okay. And then negative 2, again, up 1 over 2. Okay. And so they cross at right here, which is the point 0, negative 2. All right, and hopefully we realize again here that they have the same y-intercept, so that makes sense. They should cross right there. Okay. Moving down to number 3, it says solve by using the substitution method. So if I want to use a substitution method, I have to get one variable alone. In this case, this x looks like to be the easiest one to make that happen. Okay. I like to box the 2 that I'm going to use because you have a lot of equations up here. It can be a little bit confusing. So I'm going to take this value, plug it in for that x, using parentheses. That was my goal, to get everything in terms of one variable. Distribute positive 9y minus 3 minus 3y equals negative 15. Combine like terms, and I get 6y minus 3 equals negative 15. Add a 3 to both sides. And I get 6y equals negative 12 divided by 6. And y equals negative 2. Okay, so there's half my answer. I got to find the other one, so I'm going to plug it in right there to find the x. So I'm going to say negative 3 times negative 2 plus 1 equals x. So that's positive 6. Equals x. Positive 6, and that is 7. So my answer as a coordinate point is 7, negative 2. So if I graph these 2 lines, that's where they'll cross at, that particular point. Okay. Moving on to the next one here. Get a variable by itself, and probably getting this y alone is probably the best one. Okay, so I'm going to use that equation. I'm going to use that equation. So I'm going to take this one, plug it into that one. So I get negative 3x plus 3 times x plus 3 equals 4. I get negative 3x plus 9 equals 4. Combine like terms, that's a 0. Okay, so my variables went away. I got a little bit of an issue here. Well, I can't solve for x, so the point is these lines don't cross. Okay? And how do I know that is? Well, the variables went away, and this is a false statement. Okay? 9 does not equal 4. This doesn't work. So they don't cross. So there's no solution. Okay? So what that really means in terms of the relationship here, it's just like this. They have the same slope. You can't tell because they're not both solved for y. But if I solve this one for y, I would get the same slope as this one. So if they don't cross, they're parallel. It's no solution. Okay? Because it's defined as where they cross. If they don't cross, there isn't an answer.